Recall that exponential functions are functions where the exponent is our variable, is x. And every exponential function has two values. It has an a value and a b value, so two different numbers. And these numbers tell us different things about the function. So depending on what a looks like, if a is positive, which means a is greater than 0, if it's positive, that means our graph is going to be above the x-axis. If a is negative, or if a is less than 0, that means our graph is going to be below the x-axis. And depending on if b is greater than 1, or if b is between 0 and 1, remember this just means between 0 and 1, tells us if the function is increasing or decreasing. So if b is greater than 1, it's an increasing function, which means it's getting bigger. So it's going to go up like this. And if b is between 0 and 1, that means that it is a decreasing function, so it's going to go down. And then if a is less than 0 and b is greater than 1, then that means that our function is going to look like this. And then if if b is between 0 and 1, but a is less than 0, which means a is negative, then our graph is going to look like this. There's one point on our graph that is always true, and that's the y-intercept. The y-intercept, remember, is always the ordered pair 0a. So this is a summary of what our four graphs are going to look like. So remember our function is in the form of y equals a times b to the x. Whatever a is, this number here in front, is always my y-intercept. It's always 0a. My horizontal asymptote, which is the imaginary line that the graph gets really close to, is always the x-axis. So when you have a graph with an x and a y-axis, remember there's an imaginary line here. We draw a dashed line to represent it, that it's not a real line. It's fake. It's getting really close to that. My domain is always all real numbers, and my range is either y's are greater than 0 or y's are less than 0. It depends on if my b is positive or if my b value is negative. If b is negative, that means my graph is going to go on the bottom of the x and y axis, on the bottom of the x-axis. If b is positive, my graph is going to be above the x-axis. So if I have the equation, or I have three equations, it says which is exponential. Remember, if it's exponential, then that means that it is our exponent. So we're looking for our exponent to be the variable. And the only one of these that has an exponent as a variable is the last one, y equals 5 to the x. If I'm supposed to evaluate means to give a value for. And that anytime I'm asked to evaluate, I want to plug in or substitute. So I'm going to work this problem out, but instead of putting x, I'm going to plug in 5 because that's what they told me x was. So I'm going to put a 5 there. Well, if I put this in the calculator, 3 to the 5th power is going to give me 243. And then negative 2 times 243 is going to give me negative 486. So that would be my final answer. And if I'm asked to graph y equals negative 3 to the 2x, well, remember your y-intercept is always going to be in the form of 0 and then whatever a is, which in this case is negative 3. So I know it's going to go through the point 0, negative 3. So I'm going to go down here to negative 3 and put a point there. That's going to be my y-intercept. I know that my asymptote is always the x-axis, so that's the dashed line that we get really close to but never actually touch. And then I know because my 2 here, that's my b value because it is greater than 1, that my function is going to be an increasing function. So you can go back and look at your graph if you need to see what it looks like, the chart, but it's actually going to look like this. I know that my domain is always, all real numbers. And because my graph is below the x-axis, then my range is y's that are less than 0.